Okay, in this video we are going to look at this Laplace function, Laplace of f of t. We said if Laplace of f of t is equals to t, show that Laplace of t is equals to 1 all over s raised to the powers of 3. We first write solution, then we are going to define Laplace mathematically. Is that clear?
Yes.
Okay. We know that Laplace of f of t is equals to integral 0 to infinity exponential minus st f of t dt. Amen? Okay. So, by this definition, it implies that we can prove to obtain 1 all over x raised to the powers of 2. It's not difficult. Is that clear? Okay. So, let us show to obtain this. We know that our f of t is given as this t. So it implies that we are going to substitute in t into this integral by writing integral 0 to infinity exponential minus st, then times t dt. Amen? Now, for us to integrate this function, it implies that we are going to make use of integration by parts. Are you following? Okay. Let us define integration by parts, or we now write by applying integration by parts. Okay, we now write the formula. Integration by part is given as integral u dv equals to uv minus integral v du. Are you following? Okay. So now we are going to work with this formula to integrate this function. Yes. Let us now find our u and the v. In this integral, without one telling you, you know your u. We now write, let our u be equals to t, and let us find our dv in this integral. Our dv will now be, and dv will now be exponential minus st dt. Okay. You know that the formula here, we have integral u dv equals to u v minus integral v du. Yes, we are able to obtain our ordinary u as t. Look at it here. Then, it means we need to find our du, and we also need to find our ordinary v, which we are able to have our dv. Let us ask ourselves this question. How are we going to find our dv and ordinary u from these functions. It means you are going to differentiate this function with respect to t, and you integrate this function with respect to t, both sides. Okay, let's do it together. If we integrate t du all over the t, we are going to obtain 1. Amen? Then, we are looking for du, not du all over the t. It means without 1, you don't need a prophet to tell you. Note that we have invisible 1 here. Is that clear? We have invisible 1 here. It implies that we are going to cross multiply. If we cross multiply, we have our du equals to this one multiply du will give us du, then this one multiply 1, it will give us dt. So we have obtained our du as dt. Now, let us obtain our ordinary v by integrating both sides, both left and right. If we integrate the v, it means we are going to have v. Then this will be equals to, let us integrate exponential minus xt dt. If we are to integrate exponential minus st, it means we are going to have minus exponential minus st all over s. This is what we will have. Then we are going to substitute in these values. U equals to t, our ordinary u. Then our ordinary v equals to minus exponential minus t all over s. And the v equals to the t into this integration by parts. How? It means this is equals to our ordinary u is what? T. Amen? Then our ordinary v is equals to minus, all in bracket, minus exponential minus st all over s. But note that the integration, the integral here is running from 0 to infinity. So we should not forget that one. Integral 0 to infinity. Then minus integral 0 to infinity. Then what is our ordinary v? Our ordinary v is given as minus exponential minus st all over s. Then times, what is our du? Du is given as dt. Amen? So instead of du, we write dt. Okay. Yes. Let us obtain this left hand side by using the interval 0 to infinity. How? It means anywhere we see t, we are going to substitute in the infinity, then minus the lower limits. Okay? So now, we now write that our t, anywhere we see t, is our infinity, all in bracket, minus l minus, what is your t is now infinity, then all over, close the brackets, amen, close the brackets, then this will be minus, we now substitute in 0. It implies that we substitute in 0. It implies that anywhere you see t, you substitute in 0. So this implies that this will be 0. Then all in bracket minus exponential minus s, all in bracket 0, amen. Then all over s, then close the bracket, close this bracket. Then what we have here, minus. You know that, are you seeing what I am saying in this integral? Look at this integral. You discover that we have minus integral 0 to infinity, then minus exponential minus st all over s dot dt. So if you can see what I am saying, note that if we have minus exponential minus st all over s, you know that this is the same thing as minus 1 all over s exponential minus st. Amen? Okay. If you agree with me, it means we are going to do one thing. Please listen very carefully. It means we are going to factor out this minus 1 all over s. So if we factor out this minus 1 all over s here, it means here will now be all in bracket minus 1 all over s integral 0 to infinity, then exponential minus st dt. Amen? Okay. Yes. So if you agree with me, now let's look at these ones. You know that without one telling you, this one will be 0, and this one too will be 0. So it implies that this left hand side here, this bracket, is 0. So we want to work with only minus, all in bracket minus 1 all over s, close bracket, integral 0 to infinity, exponential minus st dt. Okay? So if you agree with me, are you seeing what I am saying? If you can see what I am saying without one telling you, you know very well that you use this minus to multiply the bracket. If you use this minus to multiply the bracket, it implies that this is what we will have. We are going to have equals to 1 all over s integral 0 to infinity exponential minus st dt. Then it implies that we will only integrate this function. Let us integrate this function. If we integrate this function, we are going to hold this 1 all over s constant by leaving it this way, 1 all over s. Let us close with the brackets. Then, if we integrate this function, we are going to have minus exponential minus st all over s. Since we have the integral 0 running from 0 to infinity, don't forget, we must write it this way, 0 to infinity. Is that clear? So if you agree with me, you can take off this part. If you agree with me, it implies that we are going to substitute this limit into this. So if you can see what I am saying, we have 1 all over s, bracket, we start with infinity, minus exponential minus s, all in bracket, infinity, all over s. Then we now substitute in 0, then it means minus, all in bracket, minus exponential s, all in bracket 0, all over s, then close the bracket, close this one. Okay? Now, without more telling you, because of this infinity, this will be 0, the whole of this. So if you agree with me, it means we are going to have 1 all over s, then all in brackets, use this one to multiply out, minus times minus, we are going to have plus exponential, sorry, we are supposed to have minus s here, yes. So minus s times 0 will always give you 0 all over s. Amen? Then, you know that in mathematics, anything raised to power 0, it gives you 1. Is that clear? So it implies that exponential 0 will give us 1. Then, we are going to have 1 all over s, all in brackets, 1 all over s. Amen? Then we have to multiply out this bracket. If we multiply out this bracket, this one will now be 1 all over s times 1 all over s. Then this will now give us 1 all over s raised to the power because 2. Because s times s will give us x squared. So you can see that we are able to show that the Laplace transform t is equal to 1 all over s raised to the powers of 2. Please, I want you to subscribe the channel and share it to your friends. Thank you and God bless you.